This is the second part of the video series for your measurements lab. In this segment, we're going to talk about the metric system, and we're going to look at some conversions. So for this lab, I do not care if you guys convert between English system and metric system. I only want you to focus on conversions within the metric system. And we're going to see that those conversions are actually pretty easy because we're going to be moving decimal places. So one of the benefits of the metric system is all of our changes in unit sizes are all based on tens. One of the major benefits of the metric system is it's a standardized system. So this means that scientists all over the world are using this system. So if I take measurements, as long as they're in metric, and I report those in something that I'm writing, scientists in Russia or China or Japan, South America, everyone will understand what size I'm actually talking about or what mass I'm talking about. So this is a great system that's, again, easy to convert as long as you're going within the metric system, and it's easy to understand whenever you're looking at the numbers. So our metric system has base units for each type of measurement that we can look at. So if we define each type of measurement, length is just the measure of linear distances. Our mass is going to be the measure of matter, so how much matter is in an object, which is different than weight. Weight has to do with how much gravity is pulling down on that mass. So if you look at mass on the moon, it's going to be the same as mass here on Earth. Your weight here on Earth is going to be more than your weight on the moon because the effect of gravity is different upon your mass. Okay, so it's very important to know mass has to do with the amount of matter. It will always be constant. Weight, it has to do with gravity pulling on your mass, and it will vary from place to place. Okay. Our volume is a measure of the amount of space an object takes up. And temperature is a measure of the intensity of heat. And remember, we talked about in lecture that heat is a measure of molecular movement. So for each of these, we have a base unit that we can look at. For length, the base is going to be meters. Okay, so think about a meter stick. When we measure mass, our base unit is grams. For volume, the base is liters. And for temperature, we're going to have degrees Celsius. So from here, if we want to change sizes of our units, we're just going to add prefixes to these base units. So here are a list of our prefixes. The base is here in the middle. So we can see that as we go up and down, bigger and smaller, we're just going to be moving by a tens place. So we'll be moving our decimal place one spot at a time as we go bigger or smaller from our base. Okay, so for example, if we needed to go bigger, we could start with our base. If we go 10 times bigger, we're going to have deca, 10 times hecto, and 10 times more, we're going to have kilo. So we can see there are exponents listed here as well. So if we take our base units, multiply them by 10 to the third, then we'll have kilo. Okay, going the other direction, we can go one place smaller. We have deci, so tenths. Centi is hundredths. Milli is thousandths. We're going to skip two places because those are not commonly used. Below that is micro. You can see that the abbreviation for micro is actually a Greek letter mu. This is kind of like a U with two tails. And the exponent there is 10 to the negative 6. We can skip two more places, and then we have nano. So abbreviation of little n, and this is 10 to the negative 9. So I'm going to show you two methods of converting within the metric system. So the first method is subtracting the exponents. So here's an example. We have 5.6 millimeters, and we want to convert it into centimeters. So our first step is to look here. We are looking for milli. So on our table, we find milli. we see that that has an exponent on the 10 of -3. So we are going to take -3. We're going to subtract the exponent for centi. And centi, if we look on our table, is a -2. So -3 minus a -2. So remember, when you're subtracting negatives, two negatives equal a positive. So we're going to do -3 plus 2, which is a -1. Now we are going to move our decimal place one position to the left. So we take our 5.6, and we're going to move that decimal one place to the left. Okay, so if we clean that up, we're going to have a 0.56 centimeters. So as you guys saw in that last problem, it's crucial that you remember if our exponents result in a positive number, you guys are going to move the decimal to the right. Okay, so think positive to the right. If our subtraction results in a negative number, we're going to move our decimal place to the left. Okay. So keep that in mind as we do additional problems. Alright, here's another example. We have 3,500 centimeters and we want to convert that into micrometers. Okay, so again, we're going to look for our exponent. We're going to start with centi, so 10 to the -2. So we have -2, and we're going to subtract the exponent for micro. So micro has a -6. So remember, -6. So -2 minus a -6, two negatives equal a positive. So -2 plus 6 is going to be 4. So in this case, we are going to go 4 spaces to the right. So we take that decimal. Remember, decimals are at the end of these big numbers. And we're going to go 4 positions right. 1, 2, 3, 4. For every space, we're going to add a 0 as a placeholder. And we're going to clean that up. And we're going to get a nice, neat number. Alright, for you visual folks, I'm going to show you another method of conversion. And in this one, we're going to take our little table of prefixes and we're just going to walk back and forth depending on which units we're converting to and from. Okay, so for this one, we're looking at millimeters. So we find milli on our table. Okay, so here's milli. And now we're going to centimeters, so we're just going to walk over to centimeters. So we see that we're going to go one position left. So now we can take that 5.6 and we're going to walk that decimal one place left. Okay, so this is going to be cleaned up, 0.56 centimeters. So this is basically the same thing, it's just using this actual table to walk it instead of using the exponents. So let's look at that other example. Alright, for this one we're going to start with centi. So here's centi, and we need to go to micro. So we're going to walk our decimal 1, 2, 3, 4 positions to the right. So again, we take our 3,500, the decimal's at the end, and we're going to walk it 1, 2, 3, 4 positions to the right. So add zeros as placeholders for each one of those. Then we're going to clean this up, and we'll see our answer. A quick note about these conversions. When you guys are being tested on this, on the quiz and on your practical, you will not be allowed to use a calculator, and I will not give you this table. So you need to be able to remember the table and put those prefixes in order to be able to do these conversions on paper. The last type of conversion you guys will need to be able to do for me in this lab are temperature conversions. For these, I will give you the formulas. You do not need to memorize them, but you will need to pick the correct one. So for example, if I tell you to convert human body temperature, which is 98.6 degrees Fahrenheit, into degrees Celsius, you need to be able to figure out which of these two formulas will be easier to use. So look at them closely and you'll see they're the same formula, they're just solved for the different variables. So one's for degrees Fahrenheit, one's for degrees Celsius. Okay. So once you figure out which formula you're going to use, you're just going to plug and chug. So put the degrees Fahrenheit into your formula and solve for degrees Celsius. Okay, so pause the video, figure this one out real quick, and you can use a calculator for these calculations. Okay, so if you guys solved that, you should see that this is 37 degrees Celsius. So human body temperature is 98.6 degrees Fahrenheit, 37 degrees Celsius. Alright, you guys need to take a few minutes now and do some practice problems for me. If you look in your lab manual, scattered throughout each type of measurement, there are conversion practice problems. So make sure you complete all of those. I will be doing a manual check to see that they are done next time I see you in the lab room.